Algebra 2, Concept 7A. In this concept, we're going to graph quadratic functions, and we're going to graph them in a particular equation form. It's called vertex form. There are three forms of a quadratic equation that you're going to learn, and this first one is vertex form. So let's start by getting down some vocabulary definitions and maybe a formula or two. So vertex form. This is a quadratic function in the form y equals a times the quantity x minus h squared plus k. You've seen this before. You know that a, h, and k are constants, and that you can find the vertex by picking out the numbers of h and k. The vertex of a parabola is the highest, either the maximum point of the parabola or the lowest, the minimum. When we're talking about graphing quadratics in their shape, which is a parabola, we'll talk about an axis of symmetry. This is a line that divides the parabola into mirror images. In a different form of a quadratic equation called standard equation form, the formula to find the axis of symmetry is x equals the negative of b over 2a. With a maximum or a minimum, we use this as a description of the vertex of a parabola. And then in particular, the y-coordinate of the vertex point is called the actual maximum or minimum. And then finally, we're going to talk about domain and ranges with the graphs of quadratics. So in general, in math, a domain is the set of inputs, or x values in this case, and for quadratic, since we're talking about quadratic equations, that will give us real number outputs. And then for a quadratic equation in general, the domain will be all real numbers, because we can put any number in for x and square it and do whatever other adding or subtracting or multiplying, and we will get a real number out. Now the range is the set of all possible outputs, and in equation form it's the y values. So for a quadratic, the range can be determined by looking at the k value. And actually this says in intercept equation form, but that would be in vertex form. So the range will be, the y values will be greater than the k value if the graph opens up, and less than the k value if the graph opens down. And when we get into graphing these, this will make more sense. Now here are some steps to graph a quadratic in vertex form. First, you want to look at the equation and anticipate any transformations from the parent function and looking at those a, h, and k values. Then remember, you're going to find the vertex, you're going to pick out h and k, you're going to find the axis of symmetry, that line of symmetry, and it will be a vertical line in equation form, x equals whatever the h value is. And then you're going to make a t-chart from the vertex, just like you've done before. 2 values in the negative direction for x and 2 in the positive direction. So look at example 1. Let's graph this. First, let's anticipate what the transformations will be. So we see our a value is -2, so we're going to have a reflection and a vertical stretch. Our h value is -3, so we're going to be shifting 3 to the left, and our k value is 4, so we're going to be shifting 4 up. Pick out your h and your k value, and then write those in vertex form. So we have the vertex -3, 4. Our axis of symmetry, we know, is going to be the vertical line x equals -3, because that's the h value. So now let's put our vertex in the table, and then remember you're going to do x values, 2 in the negative and 2 in the positive direction. Each of those numbers you're going to plug into the equation. And so there's our equation, and then I'm going to show the plug-in, and my suggestion is you put it in your calculator just as I have written it. And then you'll get the value. So plug it all in and then press enter to find the value. Do that with each of the other x values and you'll get your y values. Now draw your xy axis and label it label a scale, and then plot your points. So you can see we have a parabola that opens down, that is a stretch because it's narrow, it's shifting 3 left and 4 up. Our domain will be all real numbers, and our range, since our graph is opening down, will be y values that are less than or equal to 4, the y value of the vertex. Now let's sketch in the axis of symmetry. So you want to draw that as a broken line because it's not a definite line graphed from an equation, so you don't make it solid. And then I just draw an arrow to where at the point on the y-axis the graph starts, the curve starts, and you can see that's where y is 4. And then the parabola covers all the y values that are less than or equal to 4. All right, let's try another. So anticipate those transformations. We have an a value that's 2/3, it's less than 1, so we're going to have now a compress. Our graph's going to be wider than the parent. We're going to be shifting 3 to the right with our h value and 7 up. So let's pick out that h and k and write that as our vertex. We have our axis of symmetry at x equals h, and then place that in your table. And see how this process, you'll get used to it. Now do the values, 2 in the negative, 2 in the positive direction. And then I'm showing the plug-in of the first value just above the table. If you get a decimal, just round to tenths place. Those, I think, is the easiest way to graph. Continue, so we will get some decimal for our other values. And then let's graph them. So I noticed just by keeping my xy axis right in the middle, I still have enough graph space to graph all my values. And I do have a graph that is a little wider than the parent, and that it is, well, I might have made a mistake. I think I'm going to go in and correct that on my vertex. So domain and range, domain's all real numbers. Since my graph's opening up, that means that my range are all the y values that are greater than or equal to 7. Let's sketch in that axis of symmetry, and there I corrected my vertex because I knew my graph should have not looked so pointy. It looked a little more flattened out. And so I needed to go all the way up to 7 for that. And then notice that that's where our graph starts and then covers all the y values that are greater than or equal to 7. So those are all the important characteristics of a picture of this quadratic equation, the graph of it. Now, independent practice. So there are a couple quadratics for you to graph, and I'd like you to pause the video and graph them and then come back and check your work. All right, you're back. So let's just quickly step through, anticipate those changes. Hopefully you did. So a reflection, a stretch, vertical stretch, and shifting 1 to the left. We've got our vertex at -1, 0. Plugging in the values. Now I noticed that those values in y are negative, so I shifted my xy axis off center, which you can do. You're in charge of your graph, so you can shift it however you want so that you can have enough graph space to easily graph that parabola. Domain will be all real numbers, and the range, so you look at the y value of the vertex, which is at 0. It opens down, so it's all the y values that are less than or equal to 0. And then let's show that axis of symmetry, and then I just indicated an arrow at our maximum there, where y equals 0. And then check your second one. So hopefully you anticipated those changes, a stretch, a vertical stretch, shifting to the right and up 5. Identify your vertex, putting it in your table, plugging in those values for x. And I notice that I have lots of positives, so I'm going to shift my origin down, plot those points. So domain will be all real numbers. Range will be, since it's opening up, y values will be greater than or equal to the y value of the vertex, which is 5. And then sketch in that axis of symmetry. You can draw the arrow if you want to show that. In this case, it's a minimum point where y equals 5. Now you know the steps of how to graph a quadratic in vertex form and how to pick out all the important characteristics of this graph.